Hello, how is everyone doing? We are the Group 5, and we are here today to discuss or present our major PT in computer. So let's begin. To start off, may I ask, have you ever tried creating software applications, storing data, creating web pages, and much more? As we all know, with programming, it sincerely offers a large variety of opportunities for a newbie programmer. However, by becoming one, we must consider the core competencies for programming, wherein, let's start off with willingness to learn. When it comes to willingness to learn, a programmer needs the responsibility, determination, and motivation to learn new things, even if it means an individual will have the possibility to experience difficulties or problems. And next, we have teamwork and mentality. Engaging with other people is best not only for teamwork, but to learn and to build a relationship or bond with them. Next competency is the ability to handle failure. Frankly, programmers rarely get everything right on the first try. Therefore, future programmers should know and learn from their failure or mistakes, because being a programmer isn't really that easy, so we always start from the bottom until we succeed. Therefore, we should need the ability to handle failure. Not only that, but we are obliged to respect deadlines, because as a programmer, it is obliged to show respect for deadlines. Hence, we should try and undertake time management so that we won't end up cramming our work as a programmer. Along with that, we have grace under pressure. For some people, they see programming as an easy task. However, programming can be extremely stressful. In that case, a programmer should have the ability to handle stressful situations calmly and should have the time to rest and meditate. In that way, an individual can continue their work continuously. A programmer should also be a team player. It is necessary to engage with other people because each one of us have their own different abilities and opinions to share, and that helps to gain more knowledge and to build relationship to make such work easier and faster. We also have passion for work. With this competency, it absolutely helps an individual to succeed in their journey of becoming a professional programmer because of their passion and motivation in this course. One must also have the programming skills, because with the knowledge that you have when it comes to programming, it will truly help to modify or keep up with the latest updates about the programming language, as well as to avoid too much error when it comes to modifying or programming, as well as problem-solving skills. Just like in math problems, a good programmer should also consider being patient and have preciseness. The last competency we have is by paying attention to detail. Paying attention to detail is a must in order to avoid such errors, since if there is one mistake, everything will not function as it's supposed to be.
Career opportunities in computer programming. As the population increases, the opportunities in the computer programming field are endless and growing continuously. Thus, forthcoming students and interested people who want to make a career in computer programming should go for it without hesitation. With that being said, here are different career opportunities in programming. Computer programmers. They are developers of the computing world, in which they write, modify, and test codes and scripts for softwares and application functions. They create designs by engineers into instructions. Computer and information research scientists. They usually collab and explore problems in computing and developing theories and models. They determine the computing needs and system requirements. Computing and information systems managers. They supervise organizations and computer-related activities. They plan, install, and monitor softwares and hardwares to meet the overall information that the technology needs. Computer systems analysis. Systems architects who studies an organization's current computer system and procedures, as well as to design improvements to them. Database administrator. One is responsible for maintaining, securing, and operating databases and ensures that the data is properly or correctly being stored and retrieved besides that. They design and implement new features and troubleshoots any issues. Software developers. Software developers usually analyze what a user's needs are and spend their time creating computer applications that allow users to do specific tasks and underlying systems that run the devices or control networks. Moreover, they design each piece of an application or system and plan how the pieces will work with each other. Software engineers. It simply applies the engineering design, process to design, develop, maintain, test, and evaluate a computer software. Web developers. Web developers are those who create functional, user-friendly websites and web applications.
Software quality assurance engineer, monitoring all softwares, engineering processes, methods, and work products to ensure compliance against defined standards.
Java developer. A Java developer solves client problems using object-oriented principles in Java, a computer programming language. Object-oriented programming focuses on computer objects which contain data and code. Java developers write, compile, and monitor Java programs. They may also work on engineering and software products such as portable electronics, phones, and embedded systems. Next, we have robotics engineer. A robotics engineer designs and builds robots to improve product or process safety, operations, or quality. They also typically work in manufacturing or production settings to develop machines. Robotics engineers write, test, and monitor computer programs that direct a robot's actions. They typically create computer programs in C or C++, depending on the robot to configure. And the last career opportunity that we have is machine learning engineers. A machine learning engineer applies their programming expertise to build computer models or algorithms to gain insights from data. These models enable computer systems to learn patterns and trends without being explicitly programmed. Machine learning engineers also collaborate with data scientists to build models and may work to detect anomalies, make predictions, create automated systems, or classify.
To finish it off, becoming a programmer may be a cumulative process that builds up the skills of an individual each day. We can also say that programming can be fun and rewarding. Thus, we are here to guide and demonstrate the career opportunities in programming. If you're inspired or dream of becoming one,
the most important people in the history of programming and timeline of the history of programming. Ada Lovelace. Ada Lovelace is considered the world's first computer programmer. She wrote algorithms for Charles Babbage's analytical engine, making her the pioneer of programming. Her work laid the foundation for modern programming. Functions or purpose. She envisioned the machine to be capable of more than just mathematical calculations, suggesting it could generate music and graphics. Her work bridged the gap between computations and creativity. Hermann Hollerith. Hermann Hollerith is widely regarded as the father of modern automatic computation. He chose the punch card as the basis for storing and processing information, and he built the first punch card tabulating and sorting machines, as well as the first key punch. And he founded the company that was to become IBM. John Vincent Atanasoff. John Vincent Atanasoff and his graduate student Clifford Berry began building the ABC. The ABC was the first electronic computer to use binary arithmetic, which is the basis for all modern computers. The ABC was completed in 1942, but it was not until 1973 that Atanasoff and Berry were officially recognized as the inventors of the first electronic computer. John Vincent Atanasoff passed away on April 15, 1995 in Ames, Iowa. He was 91 years old. Colossus Machine. Tony Flowers, formerly known as Thomas Harvard Flowers MBE, was a British General Post Office engineer from England. Flowers created Colossus, the first programmable electronic computer, to aid in deciphering German-coded signals during World War II. Sermonic various vacuum tubes were employed by Colossus to carry out counting and boolean operations. Thus, Colossus is considered as the first programmable electronic digital computer in history, despite the fact that it was programmed via switches and plugs rather than a pre-existing program. Software bug. Grace Marie Hopper, an admiral in the Navy and computer programming pioneer, documented the first actual computer bug when a moth got trapped in the Marl II alchemy calculator. The term bug has been in use for many years to describe a minor technical glitch. EDSAC. EDSAC was the first particular electronic computer built in the University of Cambridge mathematical laboratory made by Maurice Wilkes and other programmers on May 6, 1949. EDSAC ran its first program calculating a table of squares and list of prime numbers. Fortran. In 1957, the first major language appeared in the form of Fortran. Its name stands for Formula Translating System. It was invented by John Backus of IBM in 1954. It is typically more user-friendly. Due to this, the components were easy for the programmers access to the computer's inputs. COBOL. Even though Fortran was good handling numbers, it was not good at handling outputs and inputs, which is important in business computing. COBOL was developed in 1959 when businesses computing started to take off. The language was designed for businessmen. It was one of the highest level of programming languages. Pascal. Begun by Nicholas Rift in 1958, its development was mainly out of necessity for a good teaching tool. It was designed on a very orderly fashion, combined the best features in the languages such as COBOL, Fortran, and ALGOL.
Next, we have C language. It was a popular language that is strongly associated with Unix, as it was developed to write a Unix operating system. And then object-oriented programming. It organizes software designs around data or objects rather than the functions and logic. Interactive TV. The Sun Microsystem decided that this needed a special and portable language and soon became Java. And last in the history of programming is Visual Basic. It was created by John Kemeny and Thomas Kurtz, which its purpose is to provide a graphical user interface which allows programmers to modify codes by dragging and dropping objects and defining behavior and appearance. It's an event-driven programming language and an environment from MS.
Programming languages and the types of numeral system used in programming. Let's start with programming languages. Imagine programming languages as the bridge between human ideas and computer actions. They're like a conversation we have with our machines. Just like we can speak in different languages, computers understand and interpret various programming languages. Machine languages. This is the lowest level language, consisting of binary instructions directly understood by the computer's CPU. Assembly language. Assembly languages are a low-level representation of machine code, using human-readable mnemonics to represent instructions. Assembly languages are specific to a particular CPU architecture. Low-level languages. This language provides more abstraction than an assembly language, but still have a relatively close relationship with the computer's hardware. Examples include C and C++. High-level languages. High-level languages provide a high level of abstraction and are designed to be more human-readable and easier to use. They abstract many low-level details, making programming more accessible. Examples include Python, Java, C#, and Ruby. Very high-level languages. These languages offer an even higher level of abstraction and are often domain-specific. Examples include SQL, Structured Query Language for database, queries and HTML, or CSS for web development.
And one of the last topics that we have is the numeral system. What's your idea when you hear the word numeral system? When we say numeral system, it can also be called as a number system that is defined as an elementary system to express number and figures. It is the unique way of representing of numbers in arithmetic and algebraic structure. To begin, we have the decimal number system. A number system is a base value of 10, and it uses 10 digits starting from 0 to 9 for the creation of numbers. And here, each digit in the number is at a specific place with the place value of a product of different powers of 10. Here, the place value is turned from right to left as the first place value called units, second to the left as tens, and so on hundreds, thousands, and etc. Here, units have a place value of 100 tens, have a place value of 100 100, as 200, 100 2000s, as 103, and so on. To continue, we have the binary number system, which has a base value of 2, and it uses 2 digits starting from 0 and 1 from the creation of numbers. The numbers formed using these 2 digits are termed binary numbers. The binary number system is very useful in electronic devices and computer systems because it can be easily performed using just 2 states, on and off, starting from 0 and 1. Decimal numbers 0, 9 are represented in binary as 0, 1, 10, 11, 100, 101, and etc. For example, 40 can be written as 1110, 19 can be written as 10011, and 50 can be written as 110010.
Octal number system. Octal number system is one in which the base value is 8, uses 8-digit IC 07 for the creation of octal numbers. Octal numbers can be converted to decimal values by multiplying each digit with the place value and then adding the result. Here, the place values are 80, 81, and 82. Octal numbers are useful for the representation of the UTF-8 numbers. Hexadecimal number system. A number system with a base value of 16 is known as hexadecimal number system. It uses 16 digits for the creation of its numbers digits. From 0 to 9 are taken like the digits in the decimal number system. But digits from 10 to 50 are represented as AFIC. 10 is represented as A, 11 as D, 12 as C, 13 as D, 14 as E, and 15 as F. Hexadecimal numbers are useful for handling memory address locations. In addition, we've come to give idea on the 6 figures we have in programming: decimal to binary, decimal to octal, decimal to hexadecimal, as well as binary to decimal, octal to decimal, and hexadecimal to decimal. To keep it simple, decimal conversion is a way of repeated division and a remainder algorithm that can be converted to binary, octal, and hexadecimal. As for converting into decimals, simply multiply its given quotient to its base, such as 2, 8, 10, 16, and add exponents starting from 0 and so on.